1 2 1 2 1 2 1 2 1 2. Woo! Try to take us through this function again, but using the a scalar draw to show us a graphical representation of what every block or every line of code is trying to do. So in a bit to do that, let's make use of this guy and then some portions and this clear space over here. Now we call the root of the function and the LC, and then we already define what this guy is trying to do, and then we say current is not none. So our current is the head of our node at this point. So let's put a triangle. Oh yeah. So let's see. So we say current is equals to current. Current is none. It's not none. So basically, we know that it's not none. It's pointing to the head. We say left count. We now call the helper on the left side of the node. So basically here, sorry, dragging the entire topic head of stuff of this stuff, right? So now, oh my gosh, we are going down the stack because we've called helper to the left, right? So we say current, so we call our current on left. So our current has changed to the current on left in here. So we are now in a different stack, and we check if this is none. Is B none? No, it's not. So what do? We check again the left, right? So we go to the left, which is D, right? And then we check again if this is none. No, it's not none. So we go again to the left, which is now finally none, right? We check it again, it is not now. Now we return 0, right? We come back up here. We are popped back up, but we are coming back up here with 0. Yep. So now we return 0, right? And now when we return 0 over here, we pop it back up. This guy, left count is holding 0 right now, right? That's what our left count is holding, because we could see it here, our left count holding 0. Let's take it, our left side is the left count and the right side is the right count, right? It's holding 0, so we enter into our right guy. Our right guy is none. Basically, it also return 0 for us. I think that's O again. So we go again now. Then our right count is 0, our left count is 0. Now our self count, we instantiate it as 0, and we say if current equals to A or current equals to B. So what's our current? It is D right now, and one of the values we are looking at, one of our so our A, right? Because we're passing in E, D, and E as our function that we are looking for. Basically, their current or their lowest common ancestor. So we pass in. So basically, A is the one pointing to this. So this guy is met. This conditional is met. It's saying if A current is A or current is equals to B, self should become 1. So let's have self be this guy over here, just 1 at the top of this. I think this is becoming too this thing, but just follow me. Let me separate it a bit. So let's have self be there. So we know that current is still pointing to this stack. So self is 1. Now we get the total. We say left plus right plus self. This is 0. Left, right is 0, 1 is 1. Self is 1. So we have our total as 1. Now we say if total is equals to 2 and LCA is equals to none, LCA should become this thing. So but total is not 2. So immediately this conditional fails. So we return total, which is what? 1. So then we come back here to this stack, and this stack over here, remember we were working with the left, and we've just returned total up back here as our left distance. So basically what we have here is 1. So I think I can remove this here. Remember we just had 1 there, and then our left has returned 1. Now we go back into our right. We go return back into our right, and what does our right do? It does the same thing this guy does, right? Because it goes through checks the left, it's none, he returns 0, checks the right, he returns 0, self count, one of it, because one of the guys, one B is E for us, because this is the guy we're looking for as well. So we found one of it, so self count is equals to 1, right? So our total is going to still remain return 1 for us, and this conditional is also going to be false because total is not going to be equals to 2. Just the same thing this is going to return as well, and we have 1 over here, right? And then we return that, and then this guy is going to point back here. Now when we come back here, remember we're going to be at somewhere at this line, right? This is where we're going to be. So we instantiate our self count again, and we say if current equals to A or current equals to B. Now current is not equal to A and it's not equal to B because B is not one of the nodes we are looking for. So self count will remain. This conditional won't be met. We transverse, and then we have total. Total is going to do what? It's going to be what? It's going to be left count, which is 1, right count, which is 1. This guy is 0. So total is going to be 2. So we say if total is equals to 2. We also give us a caveat. It says if LCA is none. So at this point, LCA is still none. So we can now say LCA should be pointing to B, right? Which is correct, right? So we point our LCA to B. Let's say we have something one guy called here called LCA, and he has a pointer as well. So it says we should point it to B, right? As well. So we point it to B, and once we point it to B, say we should return total. So our current goes back up the tube, right? Return total. So our left guy would be what? Total will be 2 right here. You understand? That's our left. So we go to our right. When we go to our, so basically, we return back to the left. We've done the left. Now we're going to the right side. So our current goes to C. Now, when our current goes to C, it has left. This guy returns 0 to the left. This guy returns 0. Okay, let's copy this guy and just keep it here. This guy returns 0 to the right, and self is also 0 because none of those are the guys we're looking for. Because we say if self is equal to A, and so for this situation where we have no value C and no value we are looking for in D and E, and we have C, right, which is none of the values we're looking for. So basically this will be 0, this will be 0, and this will be 0, and we're going to end up returning 0 to this guy over here, right? Now when current Tom returns back to this guy over here, and we're back to this, we've done right, we return 0, we return 2 over here. We say self count to instantiate it. None of these guys are this guy, so our self count over here would be 0. So our total count would be 2, which is our left, which is 0 plus 0. So we have total to be 2. Now it says if total is equals to 2, so total has been met, but is LCA none? Let's check. LCA has already been represented by some node called B. So because we have total equals to 2 and LCA is none, right? LCA is equals to is equals to it's not, it's already something, rather. It's already something, it's already pointing to a node. So this condition is not met. So we return total, and when we return total is going to return, is going to be what the helper is returning. The total is going to, so we return total, and the total is going to return something, is going to return 2 for us, and then we go ahead to return LCA, right? And basically that's it for the run. If it's none, it's going to remain none, and if it's a node, it's going to give us a node back, and basically we are coding in that sense. Now let's look at, so now we are going to move on to see the optimization, and maybe just one of basically a mental idea of what this does as against the optimization, and then the complexity as well as against the optimization.